Okay, so last video you guys saw about dip and declination and all the magnetic elements, correct? Okay, see now, if you freely suspend a magnet, what happens? It rests in north-south direction, correct? Now, see, it rests in north-south direction, that's fine. But one thing is, it's a questionable fact that see, you have Earth's magnetic field like this. Okay, so imagine like this. Now, if you keep a bar magnet, okay, now I can keep it in two directions. One like this, okay, where north comes here. Another one is like this, where north comes this side. Right. Now, don't you think the Earth's magnetic field and the magnetic field from the bar magnet, these two will interact with each other? Right. So, if they once they interact with each other, then what happens? There are certain points where magnetic field from these two will cancel out each other. Okay. Now, those are what we call as neutral points. All right. So, scientifically, if we have to define a neutral point, so neutral point is a region where the horizontal component of the Earth's magnetic field gets neutralized by the magnetic field of the bar magnet. Okay. Now, we can place the magnet in two ways. Okay. One is where north pole of the Earth and north pole of the magnet are in the same direction. Alright. See, in such a scenario, what happens is this is how the neutral points look like. So you can see those two cross, correct? The side to side of these, the bar magnet. Now those are what we call as neutral points. Alright. Now, see, any neutral point for this kind of arrangement where north pole and north pole are in the same direction. So we use the dipole formula. See, this is a bar magnet is a dipole, correct? So it's a magnetic dipole. Now, we have neutral points in the equatorial plane, correct? So what we use the formula that B is equal to mu naught by 4 pi into m divided by r cube. Okay, so remember we did two formulas. So this is the second formula what we are using, m divided by r cube. Okay, so here the horizontal component of Earth's magnetic field, that is BH, BH will be equal to mu naught by 4 pi into m divided by r cube. Okay, so if we know the Earth's horizontal component, then we can figure out what will be the distance. Alright, so this is one. The second way of getting a neutral point is, look at the figure, this is how it goes. That is when north pole and south pole are together. Alright, so you'll get two neutral points here also, and these two neutral points will be in the axial plane. Okay, so it will be in the axial plane. So again we use the dipole formula. So we will get B is equal to mu naught by 4 pi into 2m divided by r cube. Okay, since it's in the axial plane. Now here the horizontal component comes into picture. So BH is equal to mu naught by 4 pi into 2m divided by r cube. So if you know BH, you can figure out the value of r. Okay, meaning in both the cases, in equatorial as well as in axial, if you know the horizontal component, you can figure out where the neutral point exists for that particular bar magnet in that particular position on Earth. Alright, so this is the point about neutral points. Alright.